Synthetic division. In a typical synthetic division problem, you'll be given a polynomial which you have to divide by the restriction of a given binomial. The restriction of any given binomial can be found by setting the binomial equal to 0. In this case, setting x minus 4 gives us a restriction of 4, which is our new divisor term. In other problems where you're asked instead to factor or find the zeros of a polynomial using synthetic division, you must test out various values of a, b over a, and b to see which value gives a remainder of 0. Whichever restriction gives you a remainder of 0 is your new divisor term in synthetic division. In this example, we must, before we begin any type of division, we must check if the polynomial has been organized in a correct order, which is in descending degree, from degree 3 to degree 1. In this case, it has been. Then, after we check if it's in right order, we check if there's any missing x terms. Any missing x terms must be substituted with 0. And in this problem, there's a missing x term, so we substitute it with 0 into our synthetic division. Beginning our synthetic division, we bring down 3, times it by 4, which gives us 12, and we put 12 here. Adding to the negative 2 connected to the 2x squared, we get a 10. We times it by 4 and we get 40, which we add to our 0x term. We bring down the 40, times it by 4, and that gives us 160, which we add to negative 150, which is connected to our non-x term. This non-x term gives us a remainder when we add the 160, which we got from our last x term. After we got this remainder, we also have our quotient, which we got from our x terms. After we bring down the quotient, we divide it by the x in x minus 4, and this gives us our new quotient. Depending on what your teacher wants, you may have to put this in quotient or in the restatement to check the division. Talk to your teacher first before doing these. In factoring, the method is the same, but you must test out various values of a, b, and b over a. In this case, testing out negative 1 over 2 gave us a remainder of 0, and this gave us a quotient of 4, 14, and negative 30, which we divided by the 2x that came from the 2x plus 1. Anytime you're dividing by a restriction, at the end, you must always divide by the first term of the restriction. After doing this, we got 2x squared plus 7x minus 30. We factored this further to give us our zeros in this factor problem. Of course, synthetic division also has many real-life applications. It can be used to keep track of sales by using points on a graph. It can be used to approximate a function in a computer program to make a program work more smoothly. It can also be used in engineering to simplify transfer functions, making it easier to analyze stability and system response. It can also be used to analyze wave functions and analyze particle behavior in physics.